Hey guys, welcome back to another video. Welcome back to my channel. If it's your first time visiting the channel, go ahead and hit that subscribe button. There's awesome content here, guys. I know a lot of you guys watch my videos. I'm seeing my view count go up, so please just subscribe. It doesn't hurt, guys. Just subscribe. There's some awesome information on my channel. You can look through my videos. I've done, I pretty much dabble in everything 3D printers. I'm pretty sure you'll find a video that may answer your questions. So go ahead, guys, just like and subscribe. I really appreciate it. And thank you, guys. 1,000 subscribers. I appreciate you guys. This is a nice little celebration, another milestone. I know there's more to come, but yeah, 1,000 subscribers, I feel great. So I appreciate you guys who subscribe to the channel and regularly watch my content. Really do appreciate it. So thank you, guys. This nice thousands for you guys. So anyways, back to the X5SA conversion. This is part 4, the last video on this. I'm gonna go through some details. It's also Venom theme, as you can see. It looks really nice, but I'm gonna go through some details, go through some more stuff with you guys. But keep in mind, this is gonna be very informative video. I will go through some talk about some other things, my opinion, my thoughts on it, the cost, the total cost of this build, all that good stuff. So before that, let me just roll the intro. Stay tuned. Welcome back. So I'm going to go into some measurements in terms of the materials used here, and then once I go through the measurements, then I'll talk about my opinion on it. How is it running? How is it working so far, and that kind of jazz. So but yeah, let's get into it. So I'm going to go into some measurements now. Keep in mind, I did go blind joints. If you guys haven't seen previous video, I went blind joints on this setup. I didn't use the 240 extrusion. I went ahead and purchased 600mm aluminum extrusions, and that's what I'm using on the 4 corners of this build. So keep that in mind. So those are 600mm 2020 extrusions. What else? The linear rails I'm using on the Z, those are MGN9H linear rails, which is required for this setup. So keep in mind that this whole build requires MGN9 except for the X-axis, which is running MGN12H. Okay, so for the Z setup, I'm running 3 MGN9s H 400mm length. Okay, so those are 400mm length on all 3 of the Z-axis setup here. As far as the lead screw, the length of the lead screw is 350mm, and those are also TRX by 2, which means they're single start lead screw. They're not like 4 starts. Like 4 starts are what you get on the most basic and popular printers out. But these are single starts. They're better for higher resolution, and they also have a little bit more friction with the nut, so that prevents the bed from dropping when the motors are off. So there's some benefits there going with the single start setup. What else? The MGN9H on the Y-axis, so there's 2 MGN9 on the Y-axis. Those are 400mm long, but in my previous video I mentioned that they couldn't fit for this custom setup because the frame is now wider, and they couldn't fit, so I had to cut them down because they were too long. And the length and the sizing for those are now 300 and call it 393 millimeters. So 393 millimeters, very odd size to cut them down to from 400 millimeters, but that's the size required in order for them to fit. So again, this is a custom frame, so it's not quite like, you know, a Voron spec where you have even numbering for the linear rails. So 390 millimeter, 93 millimeters coming down from 400 millimeters. Okay. As far as the MGN12, that's the X-axis is running MGN12H. Now that was 500 millimeters long, and I had to cut it down to 460 millimeters. Okay, for that to fit. Now the extrusion here in front where the bed is sitting on, that was 600 millimeters long, and I cut it down to 530 millimeters for that to fit. The extrusion running from underneath the bed to the back Z-axis, that is 320 millimeters long, and I cut that down from a 400 millimeter extrusion, so it's now 320 millimeters long for that to fit perfectly with the whole setup. Now as far as the trying to go through my little paper here, because I have a little paper to kind of keep track of myself. Let me see what else that means. Make sure I didn't miss anything else. Nope, I didn't miss anything else. All right, so the top panel glass, so that means the top panel glass here, that is 544 millimeters by 470 millimeters. Now it's glass. The side panels are 570 millimeters by 470 millimeters. The front panel here, which is also glass, that is 536 millimeters by 570 millimeters. Okay, so I just want to give those numbers out, and the back is the same thing. The back is also 536 millimeters by 570 millimeters. The deck is the same. The deck is the same size as the top panel, which is 544 millimeters by 570, except you might want to cut it down just a little bit more so it fit on the inside, because remember the glass is fitting on the outside of the extrusion, and this is on the fitting on the inside. So I want to say it's, when I measured it, it was like 18 inches by 21. Just make sure you measure it to be sure, but I think that's what it is, and make sure you cut out the areas that need to be cut out so that way it sits in the frame properly. But that's the measurements. I just wanted to throw that out there so you guys have all the measurements. You can pause the video so you can repeat the video so you can hear me clearly, but that's all the measurements there is. The build plate, the heat bed, is 330 millimeters by 330 millimeters. It is a cast aluminum bed. I got that from Midwest Steel. It's a company in the USA. It's like up north, but it's called Midwest Steel. I got it from them. It's cast aluminum plate. It is 6 millimeters thick. I didn't want it any thicker than that. I think 6 millimeters is plenty, and it heats up very fast. I have a 750 watt silicone heater heating this up, and I also have 100 amp SSR powering this thing, you know. So there you go for that information. I'm also using a SKR, well, is it SKR Octopus? I'm not sure if it's an SKR branded, but it's called an Octopus board. Basically, a Big Tree Tech Octopus board is what I'm using to power this bad boy. What else? You can use an actual SKR 1.2 Pro. You can actually use a Pro board for this. The Octopus have 8 stepper driver, and the Pro, and I think the SKR 1.2 Pro takes about 6. So if you can get an SKR 1.2 Pro, that'll be perfect for this setup. But an Octopus board is perfectly fine to run this. I'm also using 92 ounce stepper motors in the back, so they're very beefy stepper motors. Totally unnecessary for this build and overkill for this build, but you know, I just want the torque and power from them, so I'm using 92 stepper motors in the back, and I'm assuming the 3 stepper motors on the Z, your typical 45 to 60 ounce stepper motor, so they're torquey still got a lot of torque in them. The total cost of this build, it cost me $927 when I added all of the stuff I spent in Amazon. Now keep in mind, I saved some money. Even though it's massive, I did save some money by, again, getting cheaper things. Like, for example, instead of going plexiglass on the paneling, I went with glass. So these are the cheap glass that you can use for your picture frame. I went to my local Lowe's and had them custom cut it to the size that I'm required, and those were like $12 for like a 24 by 24 sheet of glass, and they cut out the size out of that. So $12 versus $36 to $40 per plexiglass. I didn't want to spend that much. That's a lot of money. So plus I prefer the glass. The glass is a little bit more rigid, even though it's fragile in terms of if you put too much pressure on it, it can hairline crack and then it's over. So so I wanted to just, like I said, be careful when you're doing it with glass panel, but glass panel is also a bit more rigid than the plexiglass. So that allowed me to put some foam in between and all the panels and to keep the heat in and keep basically to close off and seal it as good as possible. I decided I was going to use plexiglass for the front, and I did use plexiglass. However, I didn't measure it correctly. So when he cut it down the middle, there was actually a gap in between when I went to mount it. So, you know, I didn't want to waste more money and redo it again. So I went ahead and just put glass panel on the front, and that just made everything much more easy, simpler and cheaper. So in the end, again, $927 in total. Not bad for a big printer. This is pretty big. I'm pretty sure if you buy a kit of this size, it's probably going to cost you a lot more, especially if you try to go build a 350 by 350 size Trident. Even if you buy a kit from, let's say, LDO, when they do bring out a kit, it's probably going to cost you, once you grab everything else from scratch, a lot more than $927. So there is some saving to be had. If you go my route, you probably can save more than I do here if you guys are efficient in terms of sourcing certain things. But again, $927 for a big size printer like this is really, really a good price. I paid $800 for this here, which was a bit cheaper than this by $100. So the 1.8 is not bad at all. And I paid almost $1,200 for this. Okay, that's the most expensive printer still. The V2.4. It's just expensive because you have to get a lot more linear rails, a lot more motors, a lot more stuff. So I would say the V2 is still the most expensive printer of the Vorons. But like I said, if you can source well, you can definitely come under, you can pay a lot less. Let me see. I was planning on converting that to a 1.8, and it's still the plan. I just don't want to touch it yet, just because it prints so well. Like, I mean, it's still such a beast of a printer, the Tronxy X5SA Pro. I don't want to touch it yet, but when I do touch it, it would definitely become a 1.8 instead of a Trident. And just because the 1.8 is just easier to build, it's just it doesn't cost that much for me to convert this to a 1.8. I just added it. It's no more than $200 because everything is already there. All the components are already there. I'm just reusing all the components, so it's no more than $200, and that's in paneling and stuff like that. I have spare extrusions from this build laying around, lots of spare extrusions. So to convert this into a 1.8 won't cost me no more than $200, and that's just for paneling and stuff like that. So that's it. But yeah, guys, my opinion so far, it prints amazing. It's printing awesome. I dialed it in, so the final print speed on this is 5K all around in terms of acceleration, except for travel speed. Travel speed is at 10K. The print speed and infill speed is 150 millimeters. The outer perimeter is 75, and it's 5K all around in terms of wall acceleration, all that. So it's pretty quick. It's very zippy. Now, I was able to push this to 15K acceleration. I had to lower pressure advance a little bit because it was leaving these massive gaps in terms of where the start and stop is for the seam. So it was leaving massive seam on there. So I had to lower the pressure advance value in order to close that seam up a little bit at 15K acceleration. So it was 15K acceleration at 200 millimeters a second. It was pretty quick. However, for some reason, Clipper was shut down. It gave a weird error, like saying like one of my cores on the Pi was overloaded, and the Pi has like 4 cores. It's weird, and I'm not sure what was happening. I'm thinking it's a bug, but it said the core was overloaded and kept on shutting down. It was printing really well too. There was no vibration lines, nothing. It was really printing very well. But I had, in the end, I had to reduce it down to 5K because it just kept on shutting off. So it could be something on my end, I'm not sure, but either way, it's printing stably now at the speed. And mostly what this is going to print anyways is PIF parts, so Voron PIF. I'm selling it on my Etsy store. I'm doing this as a favor just for the community, but it also helps to fund my channel, put some money back in my pocket, you know, just to recoup some of the stuff I spent on this. And that's really about it, not to get rich or anything off of it. It's just to fund my hobby on this channel, and to also help out folks that may not want to wait on the PIF list. But yeah, since I have a channel, you can guarantee that my parts are gonna come out clean. I will make sure they, you know, they print at quality for you guys. But either way, super happy about this, super satisfied. The total build volume on this is now what, 330 by 320. And now it could have been 330, which was the goal, but due to the coupler, let me see if I can zoom that, but due to the coupler on here, it took away 10 millimeters from it. So it's no big deal because I'm not going to print anything 300 millimeters tall anyway. So this is mostly just going to be printing ABS for the most part of it. So it does get hot right now. It's preheated. It is pretty hot in here. Like, I mean, it's toasty. It's very toasty. So right now I'm about to start a print, but before I go through that, I want to state something very important. Remember, I'm using these cheap glass. I'm really supposed to be using tempered glass in this case. Tempered glass is much better, shatter resistant, much better, much thicker, and cleaner cuts on tempered glass. Okay, this thing has cut me already. It has cut me here already. It has also cut me on my toe. It literally cut me a deep cut on my toe. It was bleeding like crazy. So be very careful of glass. And like I said, this is the thin glass. So as soon as you take something and hit it, it's gonna split. It's gonna split and shatter. So again, this is very cheap glass, so be very careful. What I'm gonna do though is, since I'm not gonna be removing these glass and the side panels, and I only really remove the front panel, I'm gonna replace this with tempered glass. Tempered glass is a bit pricey, but it's gonna be worth it because then I won't have to, you know, end up cutting myself while removing the panel. Now keep in mind, the way I have the panel mounted, I have 2 of these clips at the top. There's foaming all around to keep it sealed, and I also have like a holder, like a clip holder at the bottom in 2 spots, so it definitely keeps it nice and sealed. So when I want to remove it, all I got to do is remove these 2 screws here, 2 screws, and slide it out, put it aside, and that's how I would change it. So, but like I said, I cut myself on it already because the cutting part of it is kind of sharp. So I'm definitely going to replace that with tempered glass. So like I said, I just want to give you guys a warning to be very careful. This is very flimsy and fragile. You know, as soon as you have an airline fracture, the heat from this setup would definitely make it crack even further. So be careful because I've done it before. But overall, I'm very happy with the build. It came out great. You know, I'm just like really happy with the way it turned out. I couldn't ask for it to look any other way. It turned out better than I thought. So now I'm gonna go. All right guys, sorry about this, but future me here, I just wanted to mention the back paneling where the vinyls are on, that's wood, and it's one of those cheap wood, you know, this cheap wood you can cut with like you know, like score it and break it. It's one of those cheap wood. I can't remember what the type of wood it is, like maybe like fiberglass wood, one of those type of wood. And then the deck is also that same wood as well, the bottom deck, not the top deck, but the bottom deck, to enclose the whole bottom, that's also wood. So with a combination of wood, this thick plexiglass here, and wood and glass, it just makes for a very heavy printer. So it's very heavy, very sturdy, like I mean rigid and sturdy. So that's why I had to put handles on it, because this thing looked like it's weigh a good 60-70 pounds, pretty heavy. But I can pick it up, of course, but it's not something I want to pick up all the time. So it's fully stationed here. I have to also buy a wider coffee table. I want to say these are a cheap Walmart coffee table thing to put it on. Everything else fit on the single ones, but this thing takes up a whole thing for itself essentially. So to show you the size of the thing, it's pretty huge compared to my 1.8 and my 2.4. It's big. So for scale, it is really big. So this is my biggest printer, my first and last big printer. I won't make it any bigger than this because it barely fits through the door as it is. So yeah, so I just wanted to insert that so you guys are aware of what the back panel is made out of. All right, let's continue. Go ahead and show you my print sequence, and then I'm gonna call the video. So I'm gonna go ahead and upload. Right now I'm printing out this some upgrades for my switch wire, because I'm actually right now working on building a Enrage rabbit carrot feeder. I don't think I'm gonna do that on stream, but when I'm done, I'll definitely show you guys what mine look like. But I'm working on assembling that at the moment, and so right now I had to print out some stuff. I'm printing out the ABN fan duct mod, but I also printed out the carrot feeder head. You have to have a new head for it, for the sensor, the filament sensor stuff. So printed that out already. So I'm gonna go ahead and print this out. So I'm gonna hit print so you guys can see the sequence here. Make sure my temperature is correct. So you guys can see material 255. Yep, everything looks good. So I'm gonna go ahead and hit upload and start print as soon as it go. All right, there it is, kind of uploaded. So now we're gonna see our sequence here. I would say that right now the chamber is easily pushing, I want to say probably good 60 degrees, 65. It's pretty hot. It's pretty warm. You put your hand up there and you can feel the heat coming off of this thing. So it's well sealed, and I can't smell any ABS coming through this because, like I said, I sealed it up pretty well. All right, now it's grabbing the cookie probe. It's gonna do its Z tilt. And let me guys know if you want me to do a video of how to set up the clicky probe. I can go ahead and definitely demonstrate a video of that, and also to set up the nozzle brush as well too. I can show you guys how to do that. I might just add it to my clipper series as well. As you can see, now it's doing a bed mesh. I have a 9-point bed mesh. It's not needed, honestly. You don't need a bed mesh with the triple Z kinematics of the bed. But I like to use a small amount of bed mesh with this setup just to compensate for any little weird areas. So it's doing a bed mesh right now. I do a 3 point. I let it probe that area 3 point for the reason of it will take the average of that 3 points, which is just much better. And now it's gonna home the dock the probe. Now it's gonna home. The light changed to red, and that symbolizes that it's about to print, because I have all this set up in my slicer. Like I have all the codes for all this stuff set up in my slicer. I'm not one to put all of the start command in the config. Some people do, but that's a lot more. That would just jank off your config. It don't make no sense to me to do it that way. I'd rather just have the slicer do all that for me. Just makes it much easier to control and to keep my config clutter free. Now it's gonna do, there we go, nozzle wipe. Not that it needed it, but does a nozzle wipe. Now it's gonna home finally. Oh, sorry, not home, but going to purge right away. And so it's gonna purge. and go into printing. I forgot I changed it. I forgot, guys. I totally forgot I changed it, how the way it behaved. And there we go. Now we're printing. And that's it. So now we're printing. So I just want to show you guys my star code and everything. If you guys want any more information on all that, let me know. I'll do a video for you guys. But yeah, this is it, guys. I appreciate you guys. I hope you guys like this printer. I put a lot of work in it, and it even cut me like a Venom. I got bit by it. So yeah, I totally enjoyed this build. I'm very happy about it. It's gonna sit there and print nothing but ABS for the most part of it. So yeah, guys, let me know. Stay tuned. There's more videos to come. Again, I might convert my Pro. I'm not sure yet. Could be a Christmas thing, but we'll see. But anyways, guys, thank you for watching. Enjoy the video. Subscribe, like, share, all that good jazz. And I'll see you in the next one. Peace.